Hi everyone. In this video, I'm going to be talking about Venn diagrams. So this is going to be the lead up to the activity that we do in class on Tuesday. So make sure and take notes so that you'll be able to participate. All right, so first let's look at three different sets. So we talked about sets last Thursday, and we know that sets are just a collection of objects. So I have three sets here. It says let P be the set of kids who like pizza, let S be the set of kids who like soda, and let U be the set of all kids surveyed. So in this situation, our set U is our universal set. And like we talked about on Thursday, our universal set is basically the set where all of our sets are chosen from. Okay, so you'll see there that P, the set of kids who like pizza, are Seth, Karis, Matthew, and Richard. The kids who like soda are Seth, Matthew, Teresa, and Ashley. And the universal set, being all the kids that we surveyed, are Seth, Karis, Matthew, Richard, Teresa, Ashley, and Henry. All right, so let's say we want to represent who likes pizza, soda, or both, or neither. Visually, we can use a Venn diagram. So I'm going to show you what that looks like. All right, so a Venn diagram is basically circles that intersect. Now, you can have several different circles. Usually 3 is the most I've seen. I believe I've seen one with 4 one time. But today we're just going to be working with 2 circles because we have 2 questions. Do you like pizza or do you like soda? Both or neither? So I'm going to go ahead and set up our Venn diagram here. Oh, sorry, that was a really weird line. I just got this writing tablet, so I'm still getting used to it. So please forgive any poor writing. So what this box stands for is it is basically our universal set. So every element or member from our universal set will eventually, oh, that's really wonky. That's okay though. Pretend that's a straight line. All right, will eventually be inside this box. Now inside this box, we're going to have 2 circles, or the closest thing to circles I can make. Well, there's 1 and 2. Now one of these circles represents the set of kids who like pizza. The other circle represents the set of kids that like soda. This area here in the middle, where both of them intersect, they represent the kids who like pizza and soda. And out here, that's outside the circles, those represents the students that don't like pizza or soda. All right, so now I'm going to start filling it in based on the sets that we've had. So our students who liked just pizza, let me get back to my, where'd my pen go? Sorry, there we go. All right, students that just liked pizza would be Karis and Richard. The students who just liked soda would be Teresa and Ashley. The students who liked both pizza and soda were Seth and Matthew. But this isn't all, because inside of our Venn diagram, we have to have every single element from our universal set listed. But we are missing Henry. But Henry did not like pizza or soda. So that means he's going to go out here, outside of our circles, and I can't even spell my own son's name. One moment. Let me erase that. Okay. He's going to go out here to show that he liked neither. Okay. All right, so we kind of touched on this briefly in class on Thursday, but I wanted to mention it again. Whenever you have a universal set, So in this situation, our universal set was all the kids, and I'm going to rewrite it here so that we have it to look at. So when you have a universal set and you take part of that set, like we did for the kids who liked pizza, which was Seth, Karis, I'm going to abbreviate Matthew as Matt, and Richard, we call P a subset of U. And that is because all of the elements in P are also in U. All right, so the notation for this is P is a subset of U. So P is contained in U. There are two different types of subsets. You can have a proper subset, which is all subsets of a universal set that are not equal to the universal set. So I'll write that down here. All subsets lost my marker there for a minute. One moment. Where did it go? There we go. Okay. Okay. And then you can just have a general subset, which can be all of the subsets not equal to the universal set and also the universal set. And if you're wondering how can it be a subset if it's equal to the universal set, you have to think back to the definition of subset. The definition of a subset is just that all elements in the subset are also in the universal set. So if we choose a subset that has all of the elements of the universal subset, that still satisfies that definition. All right. Now there are formulas to figure out how many subsets there are in a set and how many proper subsets there are in a set. So I'm going to go ahead and scroll down here and give you those formulas. All right, so formula for the number of subsets. This is equal to 2 to the nth power, where n is the number of elements in the set. All right, and then the formula, let me find my pen here, I lost it, there we go. The formula for the number of proper subsets is 2 to the nth power minus 1. All right, and so again, this is where n is the number of elements in the set. That's supposed to be elements. One moment, I'll fix that. If you'll notice, the only difference between the formulas is that the number of subsets is 2 to the n, and then the number of proper subsets is that minus 1. The reason is whenever we're talking about proper subsets, we're talking about all of them minus that subset that matches the original universal set. So that's where you get the -1. Whereas when we're just talking about the number of subsets, we are including that subset that is the same as the universal set. All right. So let's look at, I'm going to show you a calculation for, let's use the set of students who like soda. Okay. All right, so I'm going to rewrite that out so we have it. So this is the set of students who like soda. In case any of you are wondering, I don't actually use the word soda in real life. I use the word pop, but then pizza and pop both start with the same letter, and so my sets would have had the same letter, and that would have been confusing. So I went with soda instead. All right, so this is my set of students or kids who like soda. All right, Seth, Matthew, Teresa, and Ashley. So we want to find the number of just subsets. So first we need to figure out the cardinal number of this set, which if you remember from Thursday's lesson is just the number of elements. So there's 4. And then we plug it into our formula. So 2 to the 4th power, which is 2, 4, 8, 16. So there are 16 subsets. So if we were to write out in roster method, every single subset possible, there would be 16 of them. I'm not going to do that though, because that would take a long time. If you want to sit down and try it, I'd be happy to look over it with you on Tuesday. All right, now we're going to look for the number of proper subsets. Okay, we know this formula is 2 to the nth power minus 1. We already said that n is 4 because that's the cardinal number of our set. So we have 2 to the 4th power minus 1, which is 15. All right, everybody make sure and pay close attention to the formulas and how I set up the Venn diagram because you will need those for class on Tuesday. I look forward to seeing you all then.